but we are excited, and this is a larger collaboration. These are the three groups that are kind of central to this, with Alexa working with Schuylkill Conservation District. But the Schuylkill Headwaters has been central to all of this work, but then many other partners who we haven't listed there, including Pennsylvania DEP, a lot of groups, individuals. So we'll start there. Anything here to say introduction to? All right. The thing that we wanted to do is get a geographical orientation, because this story of Big Creek and of Schuylkill County generally with acidification really is a geographical story, and it is unique to the locations. And so we're in the Delaware Watershed, right near the corner where you spill over into the Susquehanna Watershed. Schuylkill County, we don't have the county boundaries located here, but I love maps and topography. So we go through the Schuylkill Gap here. The little Schuylkill breaks off and goes up towards Tamaqua. The main stem Schuylkill comes up. You punch through Schuylkill Haven. And what's interesting, and I'm hoping you guys can see this where you're sitting, is that there's a lot of folded, cool features in the ridge and valley. But what we're talking about is this more rounded hill here. It is called a mountain. It's called Broad Mountain. Mountain is generously used, I think, here, but it is a highlands area with different vegetation, different landscape, different geology, and eventually we're going to talk about this little watershed, this little kind of cut in Broad Mountain here, Big Creek. But more broadly, we're going to talk about a lot of what's happening in this region of the world. Of course, in the Upper Schuylkill, it's not just the Upper Schuylkill; it's Pennsylvania generally. But this is a little bit of geographical orientation. And of course, you can see kind of the pockmark area where there's been a lot of coal development and the leftovers of that. Anything else about the geography that we need to highlight?
Not to layer.
Yeah, right. So that's where we are. We're going to talk, of course, first where we are. Alexa gets to spend some time talking about the really big picture of all the work that she's been working on, these organizations have been working on for decades. And then I'm going to dive into the more specifics about Big Creek itself and this issue of acid deposition, acid rain, as being surprisingly relevant for areas where we thought really it was coal is the big issue, and it turns out coal's not just the big issue. But not to steal all of our thunder before we get there. So, good?
Yep.
All right.
Should I jump on this side? Is that better? All right. As Eric said, he oriented us where we are in the watershed, but here's a little bit closer look. In order to understand all of these impacts in kind of the meat and potatoes section of Eric's presentation later, we want to dive in a little bit to the coal industry and those impacts and how they have impacted the watershed in Schuylkill County specifically. So there are two main types of coal found in Pennsylvania. We have bituminous coal and anthracite coal. So you can see on the western side of Pennsylvania is mainly the bituminous region, and then over here in the eastern part of the state, we are in the anthracite region. So you can see, if I can figure out this clicker, there we go. No, almost blinded you. Up here in Luzerne County, Scranton area, we have the northern anthracite coal field, and then down here in Schuylkill County, where our work was focused in the Big Creek Watershed, we're in the southern anthracite coal field. So you can see that a majority of Schuylkill County is underlain by the southern anthracite coal field. So it's a very rich part of Schuylkill County's history, something that we need to understand in order to look at the next things that we're going to talk about with Big Creek. So as I said, the coal industry is a very important part of Schuylkill County's history. It's still a very important industry in the county today even, but we're looking historically, specifically in Schuylkill County, coal was discovered around 1790. So it had been around for a while, but it really wasn't until like the early to mid 1800s that coal really became marketable. I think a lot of that came with the different navigation canals that were built in the region in those times. So the Schuylkill Canal think was up and running around 1825. I'm sure we have better experts in this room, but around that time, the Schuylkill Canal became usable. So that really opened up the markets in Schuylkill County, because now we had this method of transporting our anthracite coal down to other markets, namely Philadelphia, and then from there it could be distributed to New Jersey markets, New York City markets. So it really started to boom and bust in the 1800s. And you can see in there by 1913, roughly 80 million tons of coal were being extracted annually from the anthracite region. And then by 1917 was when it really reached its peak in the region, with over 100 million tons of coal being extracted in the anthracite region. So about a little over 100 years ago, we reached that peak in there, but that was a lot of coal being extracted from the county in those times. All right, so next, Eric found this cool coal production graph. I don't know if you have anything more to add about it.
The only thing that's funky is that it was the best graph I could find going back to 1800, and it was folks from Scandinavia, I think they're from Norway, that were looking at U.S. coal production going back that far. We found really good data from the U.S. going back to like the mid-1900s, but to get this really good graph, you had to talk to the folks in Scandinavia.
So yeah, I just think that's cool. That just shows the production, how it's steadily increasing, but you can see those spikes in there through the years. So that's historical data, a little just kind of snapshot of present day mining statistics to get an idea of past mining versus present day and what those numbers look like. You can see on there the data from Pennsylvania, that is both western Pennsylvania bituminous regions and the eastern part of the state in the anthracite region. That data is coming from. But you can see the total production of both underground and surface mines, roughly 42,500 short ton amount of coal being taken out of these mines. And then a little deeper dive in Schuylkill County specifically, our numbers there. So you can see that there's still a significant amount of coal production happening across the state and in the anthracite region, but it's nowhere near what it was at the peak about 100 years ago. So I think that's really important to remember, that what we're going to dive into is the legacy coal mining. So by that I mean a lot of the mining that was done before the 1970s, and that was when this production was much higher than where we're at today. So like I said, we're going to focus in a little bit on this legacy mining, so pre-1970s. Again, there's many more experts in here, but in 1972, so we had enactment of the Federal Water Pollution Control Act amendments, which I guess is better known as the Clean Water Act, in 1972, when a lot of these regulations really started being passed. And then more specifically to the coal industry, in 1977, the Surface Mining Control and Reclamation Act was passed. So as part of that act, that actually established the Federal Office of Surface Mining, Reclamation, and Enhancement, which is now the federal agency that oversees, regulates mining from both legacy mining and our active present-day mining. So that SMACRA Act established OSMRE. So that is really where these regulations started coming into play. It's important that before 1977, coal mining was pretty much unregulated. So these companies could come into an area, mine the area, do whatever they needed to do, and then they got out of there with, they didn't have to reclaim that area, they didn't have to treat any water that was coming out of the mines, they didn't have to clean up like their cone piles, things like that. They would come in and they would leave. So all of those areas that were mined were producing some degree of pollution. So whether that was coming from abandoned mine drainage, which I'll talk about in a little bit, that sediment runoff, lots of different issues with coal mining operations. But a lot of the impacts from these past mines are still really felt today, and that's what we focus on at the Conservation District and at Schuylkill Headwaters Association, which is the main nonprofit watershed group that does work in the upper Schuylkill River watershed within Schuylkill County. So it kind of, the responsibility to clean up these mine discharges and mine areas has fallen a lot on the state and the counties, because these are abandoned sites that nobody was responsible for prior to 1977. Anything that's happening after 1977, like I said, now all these mining companies have an obligation to reclaim what they were doing. So they have an obligation to treat any discharges to water quality standards. They have to put refuse and overburden, things like that, back into what would have been close to a natural contours and topography of the area. So we don't see as much of the issues today, but the legacy mining is where the issue lies. So again, I'm going to focus a little bit more on the abandoned mine drainage, so not so much the refuse or any other issues, but the actual mine drainage that is coming out of the mine. So you can see in that picture, pretty easy to spot, but AMD is the #1 non-point source pollution issue in Pennsylvania, so it is a big deal. It impacts over 5,500 miles of streams across the whole state, so both eastern and western regions, but then more specifically, roughly 130 miles in Schuylkill County are impaired due to abandoned mine drainage. I'll get into the studies, I think, in the next slide or two that identified these, but there were about 108 AMD discharge and recharge sites, so that were identified in the upper Schuylkill River within Schuylkill County. By discharge and recharge sites, I mean that's where water is actually coming out of the ground and is polluted with AMD, or an area where clean water is getting into a mine pool. So whether that be through a stripping pit or something like that, but where clean water is going into a mine and is coming out somewhere else polluted. So 108 of those sites across Schuylkill County, and then 35 of those were identified in the Little Schuylkill River watershed. So this is a map of Schuylkill County. This map is a little bit old. I said this needs to be updated. I realized through doing this presentation we should update our map here. But some interesting data. Again, this is Schuylkill County, and you can see in this little inset map, again, that's a zoomed in on the southern anthracite coal field. You can see in Schuylkill County, all those little orange dots are those identified AMD discharge recharge sites. I'm not sure if we mentioned, Schuylkill County is almost split in half between watersheds, so about half of it drains to the Delaware and about half goes to the Chesapeake Bay. So this map obviously includes everything, but the easiest way for me to do the Schuylkill watershed is about like that, kind of the, that area is the Schuylkill watershed, and then the western half drains to the Chesapeake. But I think it's pretty, when you see all those dots on there, it's impactful, all those mine drainage discharge sites, and then the squiggles on the map are our stream miles and the impairments that were determined from those. So the orange line streams are listed as impaired due to AMD. This would come from the DEP's integrated list of impaired waters. And you can see, obviously, the streams impaired by AMD correlate with where the discharges are coming from, and it really sets up nicely with where the coal fields are found. So kind of diving into a timeline and history of this work, and I'm sorry, I'm going to look at my notes for this because I don't want to mess up these dates. And a lot of important information on this slide, but a lot of this work, specifically in Schuylkill County, but also across the state, really started to ramp up, I think, in the 90s and 2000s in terms of environmental work and work focused on the coal mining industry and reclaiming that. So in 2001, the Schuylkill Conservation District and Schuylkill Headwaters Association collaborated to get a study done, and actually, I don't know if anybody knows Bill Reichert. I worked with him. He's president of Schuylkill Headwaters Association. He's been around for a long time and was really integral to a lot of this work being done. But I sat down with him. He would have loved to be here. He couldn't make it today. But I sat down with him this past week to get a little bit of his personal history. But he shared that it was actually Cherry Town who encouraged the district and Schuylkill Headwaters to do this assessment in 2001, that she was the one who kind of pushed that along. So, like I said, the district and Schuylkill Headwaters teamed up and did a whole assessment of the upper Schuylkill River and all its tributaries within Schuylkill County. You'll hear me refer to that as the Kimball and Associates report, because that was kind of the first one that took a deep dive into all of this. So this was the report that identified those 108 mine discharge sites. Again, that was done in 2001, so that data is probably different now. That things have changed, more discharges have popped up in that time. But they took a lot of existing data from DEP that DEP had into this report, but then they also opened it up to the public and had a public survey out there. And Bill said that's when these numbers really started to jump up, when the public came forward and started sharing where they knew there were these mine discharge and recharge sites happening across the watershed. So that was an important study. And then also in 2001, there was a rivers conservation plan developed by Natural Lands Trust, and that was watershed-wide, the whole Schuylkill watershed, but it did have a section of it that focused on AMD in Schuylkill County. And then also, same thing in 2002, the State of the Schuylkill River report was done. That was watershed-wide also, but there is a section dedicated to the AMD issues. So from 2001 to 2002, a few very important studies were conducted that kind of outlined what was going on, the issues with the coal mining industry, these discharges, and started to put together a plan for how to go about remediating this and treating it. So then you'll see next in the timeline, I have 2004 was really the start of the county and the state building larger scale treatment systems on some of these bigger AMD discharges in the county. So I always say they dove right in, they had these studies done, and then about 2 years later they were starting to build treatment systems already. And then 2007 we had the Upper Schuylkill River Watershed TMDL, Watershed Implementation Plan developed. So again, that was really an assessment of the whole Upper Schuylkill watershed. It started to lay out now these discharges and list them in a priority order. So we looked at the metals loadings from these different discharges and put them in a priority order of how we wanted to work through them. 2011, the Schuylkill River Q-Hub was developed, so just another plan somewhat similar to the WIP. That opens up additional funding to go after treating some of these discharges. And then the first one that I was personally around for was in 2019 when we did the Upper Schuylkill Watershed TMDL Implementation Plan revision. So same as the 2007 one, just 10 years later, a lot of work had been done in the watershed, a lot of things were changing. So we worked with DEP and EPA to update that plan, kind of reorganize our priorities based on work that had already been done and what we still needed to do. So these are all the plans that really drive our work in the watershed. And Bill wanted me to note that it was also important when the state started giving funding to the counties to have watershed specialists on their staff, because these people were really dedicated to doing this work. So I think Schuylkill County got their first watershed specialist sometime in the early 2000s. And that position, I think the main job duty of that position at our office is dealing with the AMD issues. So they've been able to get a lot of work done. So this chart, again, now this is pulled from the most recent revision of our WIP. The WIP is broken out by sub-watersheds in the whole Upper Schuylkill. I just pulled out the main stem, which we kind of looked at as a sub-watershed because there are many discharges in the main stem. So this is our priority list. Going through the first column there, you'll see a ranking that's based on overall metals rank and loading into the whole watershed. And then the next numbers correspond to the location as they're moving through the watershed. So we do have the first 11 because we're in the uppermost part of the main stem of the Schuylkill River here. And then that is a list of our priority discharges, and it gives a status of whether we have any treatment on these discharges or not. So you'll see, and this is important in the next map, but we do have, I think there are 4 on this list that are completed, and the rest of them are either currently in progress or still to be done. So this map, again, based on our table in the last slide, you can see, hopefully you can see back there the color isn't the greatest, but this pin right here is marking the very most headwaters of the upper Schuylkill River, so close to Tuscarora. The river flows, kind of follows Route 209 down here, and then we hit our Mary D overflow treatment system, the Mary D borehole treatment system, and then the Bell Colliery treatment system. So these are 3 major treatment systems that are constructed, they're up and running, they're functioning, they're treating water within the first several miles of the upper Schuylkill. And then you'll see where Big Creek comes in, so starts up here and flows down, and Big Creek enters the Schuylkill River just slightly downstream of where these 3 treatment systems are treating. So that's important for what Eric's going to be talking about.
And I'm going to jump in just really quickly because I don't have this aerial photograph in any of my slides, but you can see how, right, there's land development and land use change down in the valleys, but look at how contiguous the forest is up here on Broad Mountain, right? Almost all of these reservoirs that you see are drinking water reservoirs, and the municipalities actually own a lot of the land to protect their drinking water reservoirs. But it is beautiful forest, right? You would expect these to be these great, pristine, beautiful streams. So this, I just wanted to take that moment to jump in. Sorry to interrupt.
No, that's fine. But yeah, I think this just really emphasizes that there's a lot of disturbance and impacts in the first several miles of the upper Schuylkill River already, and we are working our way down through the watershed on treating these. There is another treatment system down here, so this is downstream of Big Creek, but that's our Silver Creek treatment system, and that is the last of the 4 that we have completed on the upper main stem Schuylkill. And then, I'm not going to read all this, you guys can read this, kind of gives an overview of those 4 existing treatment systems. So just in general, the type of AMD treatment that we do is all passive treatment systems. So there's passive treatment and active treatment. If you think of active treatment, it's kind of more of what you would see for like a water sewage plant. There's operators there, there's tanks, they use chemicals, peroxide, things like that to get those heavy metals to settle out of that water. But we do all passive treatment because pretty much in Schuylkill County it's 2 of us that do the work. So we don't have the manpower to do these active treatment systems. Active treatment is also very expensive and maintenance heavy. You need to have somebody pretty much at these plants every day, where our passive treatment systems usually just consist of settling ponds and wetlands. Depending on the water quality of the discharge, we also do some limestone drains with piping to boost the pH and alkalinity, but pretty much just basic series of ponds and wetlands. We want to get those heavy metals to precipitate out of the discharges, collect them in our treatment systems, and send cleaner water back into the stream. So, like I said, just some data on our treatment systems, but we talked about, I think, I wanted to note this, and Eric will probably go into this more, but I think it's really neat. After all these treatment systems have been built, you can see the dates in there. Silver Creek in 2010, the Mary D East overflow, which actually that's a DEP treatment system, completed in 2009. The Mary D borehole system completed in 2013, and Bell Colliery was the first one, completed in 2004, and we've done several retrofits on that system, but it's in its existing state, it was completed in 2013. So a lot of that important work was done. The water coming from these treatment systems is pretty good quality that we're sending back into the river, and actually I don't know when it was classified. It was within the last couple of years. The upper Schuylkill River from Brockton, so I'll go back to this slide. the river from Brockton, which is right where Big Creek enters the river, and upstream was classified as a Class A wild trout stream for brook trout. So that's great, just a little boost to know that the work that's being done is working, it is helping the Schuylkill River. But with all that being said, all this work was done upstream. Kind of the next thing on the radar is now Big Creek as we move downstream. So I think that segues into Eric's section. Yeah.
Oh, and before we move on, of course, like mentioning Bill Reichert and all of the important work that Bill has done through the years is also to mention, and Michael Hartshorn mentioned this in the keynote presentation, is the Schuylkill River project. We aren't diving into all of the impacts from the coal mining, but certainly the refuse coal, the comb, the coal silts being in the main stem Schuylkill River is a really great story of the restoration. Cherrytown, who works at the Delaware Riverkeeper Network and has for many years helped organize this Congress, literally wrote the book on that and got a grant to write that book. A great book if you want to read it, but also if you want to take the short version, in 2016 she gave a presentation about that whole Schuylkill River project. So, right, a lot of issues have been dealt with. One of the ones we're not going to talk about today has been covered thoroughly, so go to that YouTube link, it's great. And it was when Cherry didn't have, yeah.
Oh yeah.
Yeah,
Sure.
problem with her voice, so.
I'll pass it off.
Great, all right. So now we get to talk a little bit about Big Creek. And Jay's telling me I have 15 minutes, more or less. I can talk pretty fast. I might take a little bit more, I might take 20 minutes. Next is lunch. Nobody really, right? We're here to talk about science. We don't really want to eat, so we can just go all through lunch too. If anybody wants to stick around, please feel free to do that. So one of the take-homes is that there are a lot of issues with acidic conditions in these streams in Schuylkill County, right? The legacy of coal mining is manyfold, but including really acidic water coming out of these coal. And I don't know if you mentioned it, Alexa, but some of these mines come out really alkaline. It's not the majority of them, but that was something that I didn't know before I got involved. I think it's Wadesville mine pool, right, that they use for Limerick. Actually comes out with a lot of dissolved salts, beneficial calcium, magnesium, but a lot of these are really acidic, and you get this very characteristic community of bugs, and usually a total lack of fish in these areas because of all the acidity. And so that's when I got invited to the table was, I went backwards, Alexa, Bill, all of their partners, Pennsylvania DEP, had started moving downstream and working on Big Creek. Again, we're up here on, moving down from the valley. Brockton is probably right about here in the watershed and moving down into Big Creek. And it's a weird system, and we'll talk a little bit about the kind of unique history and kind of peel back the layers of the onion, because that's, I think, kind of how we discovered it. Is we kind of dove in, and we thought we had things figured out. And we're like, oh, that's new, okay. Adjusting our thinking about Big Creek. And then the next layer, and it is a many-layered system. It's a small forested watershed. A lot of, particularly the upper part of the watershed, is entirely owned by Blythe Municipal Authority for drinking water intakes. They have drinking water intakes adjacent to Big Creek on Silver Creek, as well as about halfway down in the watershed. I have a little pond called Moss Glen Reservoir. The funny thing is that it wasn't until the 1940s that a coal seam, a small coal seam that lies underneath this stripping pit and under Silver Creek, was first developed and mined as a strip mine. And so that's where our story starts, is that work that Alexa and Schuylkill Headwaters and Schuylkill Conservation had done. They developed the cold water plan, and it just said that the entire main stem of Big Creek, all the way down to the confluence with the Schuylkill, was highly acidified. Classic AMD, like you had the bugs, the leuctrids, and the nemorid stoneflies that you always get in these really acidified streams. There were no fish at all. It just looked horrible. I mean, some of the samples, they only were able to find like 20 or 30 aquatic macroinvertebrates in some of their samples. So it seemed like a classic case. In the 1940s, the very upper part of the Big Creek watershed was allowed to be strip mined, but because of these drinking water intakes, they had some conditions. They said, all right, we got to keep that bad mine water away from our drinking water intake, so they built a bunch of bypasses. And so the first one is that the spillway for Silver Creek Reservoir, where Blythe has one of its drinking water intakes, actually doesn't spill towards Silver Creek, it actually spills towards Big Creek, but they didn't want that to spill into the old strip mine, right, and get polluted, so they built the first bypass channel up and around the stripping pit and into the natural channel. So, and I don't know if everybody can see this from the back of the room, but there are two blue lines here. The northern blue line that is more squiggly is the natural creek channel for Big Creek. And then the lower channel, the southern channel here, is the second bypass that they built. As the old stripping pit got flooded, and there's some interesting stories about how that happened, and I don't know that we have that story entirely straight. As that flooded, they wanted to keep that flooded strip mine water out of these drinking water intakes, so they carved a channel in the southern slope of the mountain, perched above the natural Big Creek channel, all the way down, for it's about 1 mile to 2 miles, and then reconnected. We have some little red lines where USGS got the hydrology wrong, but it ties in just below where the drinking water intake is, right? Keep the polluted water out, we'll let you tap into the coal seam. But then through the years, of course, and it was in my last presentation, the folks working in the Cobb's Derby, where they say gravity always wins, right? Gravity's a powerful force. So, of course, you build these channels, you try to keep water away from it. It doesn't work. Yeah, it was your guys' presentation. And so, first of all, the bypass around the stripping pit didn't work, and so one of the highest waterfalls in Schuylkill County now is where this bypass water goes straight down into this beautiful strip mine here. But the other two ways that the original engineers were bypassed was at a power line crossing here, ATVs and four-wheelers running up and down it. So now there's water flows from this old stripping pit bypass channel to Big Creek here, and then there's actually a pipe connection. Eventually, the municipal authority said, we sometimes need that water. During drought, we need some of that water to come in above our drinking water intake so that they have a connection there. So the hydrology, again, talking about the many impacts of 200 years of coal mining in this area, are manyfold, and they reach into all kinds of interesting ways. So one of our first discoveries was the hydrology was even more complicated and messed up than we thought. And then, again, really acidified. I'll just kind of keep on talking this. So this is, Alexa put together this slide talking about the early surveys. Mike Kaufman was another key player from Fish and Boat Commission who started to look at this, found no fish, really low pHs. He's like, but this beautiful habitat, again, this is an entirely forested watershed. Lovely stands of rhododendrons, really good hemlock forest, young hemlocks growing there. You walk into the stream, it looks fantastic. You think it's going to be just this great site of biodiversity, and in fact, there's almost no life in the stream. And so really concerning, and Mike highlighted that and said, this is an opportunity for restoration. Again, the 2000s and then 2012 with a cold water plan. And then, this is before I was involved, the Schuylkill Conservation District and Schuylkill Headwaters said this might be an opportunity to introduce some limestone at the outlet to that strip mine, because it looked like, again, that strip mine was the source of all this acidity, right? It's a classic case in Schuylkill County. You go to the mines, yep, it's super acidic. We treat the mine outflow, and we can remediate the whole watershed. This is a little bit of history, a couple years, 2016, 2017, and then a more intensive effort, including some plans for this fall for continuing that and probably going beyond 2023 for limestone sand. We first, Alexa, and then I got involved, is just putting the limestone sand in that artificial channel, in that bypass channel that comes out of the strip mine. Pretty dominant source of the overall hydrology, so it treats a really large fraction of the total water that flows down through the Big Creek system. And it's been really effective at raising the pH for the system, right? So it works. Limestone sand in these systems can lead to very important improvements of water quality. And so this is from May of 2021. Oftentimes, late winter and spring, you can get these really acidic pulses coming through these acidified systems. But we see that with the limestone sand, a pH of around 4.8 in the stripping pit, very stable, 4.6 to 4.8, almost entirely in that very narrow pH range year-round in the strip mine. But you're talking about pHs in the 7s, or almost 7 by the time you get back down to the Schuylkill River. So good, thanks. Good response to the water quality. We're not going to dive into a lot about the limestone application because the story, that's only the second layer of the onion. So good response. We're thinking things are going well. But some of the things looked a little bit weird. The bugs in certain sites look fantastic. We're getting year-round populations of some sensitive mayflies now down in Brockton near the confluence with the Schuylkill River, right? A sign of success. It still doesn't look like a natural macroinvertebrate community. It still looks like, at least at times of year, like an AMD bug community. Like you compare it, and there's actually even in the assessment a little trigger to be like, is this an AMD bug sample? And sometimes these samples do trigger. But in other parts of the watershed, like above where that first connection occurs, there are no mayflies at all, right? So some peculiar water quality data, some peculiar bug data, and we're like, well, the limestone sand seems to be working, but we don't. It doesn't seem like we've got everything figured out here in Big Creek. So we, as part of the Delaware Riverkeeper Network getting involved, we started to spend more time looking at bugs in different areas and started to measure pH a little bit more broadly. You take those same pH meters and you dunk them into all these intermittent channels that flow into Big Creek above and uninfluenced by the coal mining, and you start to see pH is sometimes worse than what you see in the strip mine. 4.6s, 4.7, 4.8. We're like, whoa, wait a minute, this is weird. Maybe it isn't all the coal. We go then further outside of Big Creek, go up on top of the mountain, we go over the next watershed. You sometimes even see worse pHs, again in an area uninfluenced by coal mining, 4.2 to 4.4 for pHs in the upper Wolf Creek watershed, just off the Burma Road. It was like, oh wow, like we actually thought our pH meter was broken, right? These are really dilute waters. The conductivity for Silver Creek at this site is usually 10 microsieverts. It's almost like the distilled water that you would buy from a grocery store. So we're like, maybe these pH sensors aren't even working. But then a pattern started to emerge. We kind of double-checked and triple-checked our different sensors, recalibrated them, is that up on top of Broad Mountain, where you're getting spring sources, true headwaters, you're seeing pHs that look like the current wet deposition, current rainwater of mid to low 5s for pH. Oftentimes when we're at Silver Creek at the Fire Tower Road, we see 5, 5.2, 5.4. There's a little spring source that flows into this unnamed tributary to Locust Creek. Same thing, if you're at those, really at the spring heads, you're seeing low 5s rather than these mid 4s. And so it's a little bit acidic, but it kind of reflects rainwater and snowmelt. But then if you go further north and come off the top of the mountain and go towards Locust Creek, now all of a sudden those pHs are more neutral, right? Now we're seeing everything in their 6s, right? If you're in the campground at Locust Creek State Park and you go to all these different little small tributaries, 6.2, 6.5, 6.4, and it started to develop like, are we going crazy here? Like, literally, if you're on the wrong side of the mountain, you're dead. You literally, you have no hope for trout, for a lot of the bugs. And this is where we started to look at the geology to try to figure out, like, is there a really big change in the geology? And none of us on the team are great geologists, I don't think. So we looked at this map and we're like, whoa, wow, there really is a change. This is Big Creek in the green, which is the Pottsville Formation. The coal-bearing areas are the Llewellyn Formation in this light beige or light yellow. And then the Mound Chunk Formation is in the red. And so up on top of the mountain, you have a mix of the Pottsville and Mound Chunk. As you go down to Big Creek, it's all Pottsville. As you go down to the headwaters of Wolf Creek, where those 4.2 to 4.4s are, it's all Pottsville Formation. And then as you get into some of these other tributaries in your Mound Chunk. So it's like, all right, maybe this is part of the story, is the geology. Pottsville is a sandstone. The Mound Chunk is more of a siltstone. But it really wasn't until we started talking to some other people that were working on the problem more broadly, especially Matt Shank he was a colleague when I used to work at the Delaware River Basin Commission. Matt was working at the Susquehanna River Basin Commission, SRBC, and we're working on separate problems. I had to call him about a separate issue. In this part of the Schuylkill River, we don't have American eels, and that's part of the problem with invasive crayfish for the main stem Schuylkill here and some of our tributaries like in French Creek and Pickering Creek. I was calling him about that, and he's like, "Oh, what else interesting are you doing?" I'm like, well, you know, we can't figure out this mountain. Like, literally, if we're on the wrong side of the mountain. He's like, well, he literally, while we're on the phone, pulls out his GS, and he's like, well, you're in the Pottsville. And I'm like, yeah? And he's like, well, the Pottsville, throughout the state of Pennsylvania, we're finding it without any mining in the Pottsville Formation, as well as at least 5 or 6 other geologic formations. Those streams look like AMD streams. They look like they're totally cooked out. The pHs are off in the 4s. Usually there's no fish life in those streams. And this is something that's ongoing to this day. Another person that we ended up speaking with, I worked with Pete Sharp from the National Park Service on the Delaware River and some issues with New York City's reservoirs. And Pete's like, oh yeah, we're working on the same thing down in Shenandoah National Park as well, and we have the same kind of issue. So there's this broad thing that you have different geologies responding, even though, and I think I can do 5 minutes, more or less, to the improvements, despite the fact that I think, and I'm going to show a couple slides showing how we've done a lot better with emissions from smokestacks, emissions from smelters, and acid rain really isn't something you see in the news anymore as a big deal. Maybe if you're up in the Adirondacks or the Canadian Shield or something like that, you think, oh, maybe some of those lakes haven't totally bounced back yet. It's not only that they haven't bounced back, like it is actually getting worse. Again, rainwater in the mid-5s is getting worse by the time it gets down to Big Creek and to Wolf Creek and to other places. So it's not some kind of old threat and things are just slow to come back. It looks like they're not coming back at all. And this is data originally from Mike Berta, the new regional fisheries biologist from Fish and Boat Commission. And he pointed out, he's like, when you shared your map of the geology, that perfectly lines up with what we're seeing with brook trout as well. That in areas with the Mauchunk Formation, we have at least remnant populations of brook trout or really strong populations of wild brook trout. But, and the best example of this is here in the Wolf Creek, right? 2 tributaries to Wolf Creek connected by a reservoir, so no barriers for fish movement. And one branch has a wild population of brook trout. The other branch is totally fishless. And the only difference is a little subtle change in the geology. Mid-5s for pH over here in this unnamed tributary, and again, low to mid-4s for pH in Wolf Creek. So it's not something that was old. 1990 were the amendments to the Clean Air Act that started to lead to improvements in air emissions, right? Really high sulfur and nitrogen oxides that have been cut at least in half over that 30-year period. So really good improvements. pHs, again, low 4s or in the 3s in our region, back in 1985 before those emissions. And again, now pHs like what we see up on top of Broad Mountain in the mid-5s. So big improvements, kind of what you expect just through natural atmospheric chemistry. A little bit acidic, but mildly acidic. Not lethal concentrations. Again, going back to the graph that we talked about, as we start to think about Big Creek and we think about timelines for how long has Big Creek been acidified, again, 1940s is when they mined the coal out of there. Were there brook trout there? Or with coal mining, particularly in Schuylkill County starting in the early 1800s, has that been cooked out even since the 1800s? There's the big peak in the late 1800s, a little bit of a dip from the Great Depression, World War II, another spike. So some substantial amounts of probably atmospheric deposition, low pH, going back 100 years, but uncertain. And this is one of the problems, is that we don't have comparable data in systems like Big Creek or in other parts of the Appalachians where people were consistently measuring pH, they were consistently measuring rainfall. And so this is one of the hard things, is that when you have a graph of coal usage now rather than coal production, you see a ramp up, and we know that things were regulated beginning in the mid-80s to around 1990, Acid rain and acid deposition were first discovered in the 50s and 60s. Again, like always in our beautiful democracy, it takes 2, 3, 4 decades to take action before we're convinced that the scientists, yes, indeed, were right. It is acid rain causing the problem. But then you can get big improvements with those regulations, but it leaves a fair amount of uncertainty still in our timelines for how long these streams have been acidified and how long it might be for them to naturally recover, right? Even in the possible formation, is there a chance that with the decreases in the sulfuric acid and the nitrogen oxides coming down, will it bounce back? But when you look back, and I'm going to go back to that graph, right, it's at least been a decade and maybe 2 decades and at least 30 years since those Clean Air Act amendments were passed. Big Creek has had a while to recover, and it doesn't look like it's recovering probably at all. And in fact, we have some anecdotal stories, people that would fish these streams growing up in the 50s and 60s. Silver Creek, I think, is the best example, where there were so many fish that these little kids could go in and catch dozens of fish in either these fishless streams or streams that are marginal, where there might still be a relic population of brook trout, but there's only a few left, and so it would be hard to fish those streams. So some interesting timelines for questions about acid deposition, when these streams were acidified, how long they're going to come back. So again, we were surprised. I think this is, well, it's probably not the last layer of the onion, right? I mean, this is our current layer, like, oh my gosh, just in the last 12 months, we're like, wow, it really isn't just about the old strip mines and coal, right? Adding insult to injury in Schuylkill County now is you have the particular geologies, and it's not the only geology, and it's not only in Schuylkill County, it's throughout the state of Pennsylvania. Certain geologies have been cooked out by decades of acid rain and acid deposition, are not bouncing back. Other watersheds are bouncing back, have great biological communities, including wild populations, brook trout, the classic stream bugs that you might want to see, beautiful ephemerellids and heptageneids and things like that, whereas other streams are not bouncing back. So in Big Creek specifically, we're continuing to explore our options. We're certainly continuing with the limestone sand to treat the acidic water coming out of the stripping pit. But we're now recognizing that, right, that's not the real source of acidity. The real source of acidity, is the geologic formation and the interaction between the rainwater and what's happened. And so we're doing some soil sampling, starting to look at the terrestrial ecosystem. We've done some pilot tests where some small plots we're adding either limestone or dolomite to terrestrial systems, looking at the response of those soils. And really to look at the watershed response, we probably need to be thinking about catchment scale applications of limestone or dolomite. John Jackson, who many of you might know, kind of nudged me before the talk today. And he's like, there is some evidence that some streams in the Appalachians were, somewhat acidic. And so that's, I think, one of the questions is, with the possible formation, it is a poorly buffered system. Those sandstones didn't have great buffer capacity. So, before people were recording, how low was the pH? And to think about what our endpoints are and what restoration really means in a system like Big Creek. And then finally, just the general conclusions that coal continues to bite us in the tail a little bit here, right? There are the AMD sources. They're relatively easy to identify, can be difficult to treat, and take a long time. Talking with Bill and Alexa and some of the other folks, some of that acidic mine water is attenuating a little bit over the last 20 or 30 years, but we probably have really, really long time frames to think about when those mines start to reduce how much acidity and metals they're loading into the system. So a lot of work remains for dealing directly with the AMD, but now we're also having to think about the fact that, at least in certain settings, the usage of coal has cooked out our systems and devastated the biology and the ecology. And again, talking with folks like Pete Sharp from the National Park Service, it's not just the streams where my head is always focused underwater, but it's the terrestrial ecosystems. Really big problems for which species of plants are in those systems, the health of those plants, their growth, and so probably the whole ecosystem needs to be examined for this. So with that, contact information for Alexa and me here. I don't know that these points are earth-shattering, so it's probably more important to put up a beautiful photo of Lake Caporal. This is the stripping pit. This is what we thought was the big source of the acidity. And it turns out that it's, again, there's a guy, I think he was British, but he was a professor up in Canada named Noel Hines. And one of the foundation papers you read as a stream ecologist, right, is a stream in its valley, right? The setting for your stream, right, reflects your landscape. And you know, that was brought back to home for Alexa and I and all our team here. So thank you. I hope we still have time for a couple of questions. And if people don't want to go directly to lunch 5 minutes from now, I will commit Alexa to sticking around for a little bit longer afterwards. So thank you. All right, that means you have to come this way, Alexa, to answer questions.
I don't see any hands up.
Yeah, I'm sure there's not going to be any questions.
Yes.
All right, just real quickly, I'll just, my closing reminder, if anyone needs an attendance form signed, I'll be here, I can do that, and I'll let you go to Eric. And Alexa.
You maybe address this a little bit, but just to kind of re-ask it. My question is, did those streams ever have brook trout in them? I mean, you said that Silver
Creek, yeah.
Creek did, but I wonder about those little headwater ones.
Yeah, so as far as we know, we don't know of any records of fishless streams, you know, in this part of the Appalachian Plateau or Ridge and Valley,
okay.
right? So we don't think so. And again, our best answer to that is the data collected by a bunch of kids going fishing, right? So Silver Creek, again, it's one of the ones that is marginally neutral, right? pH 5, 5.2, 5.4. And this is an area where this fellow John Bondura would fish as a kid. They would ride their bikes up from New Philadelphia, a substantial amount of time and effort to get up there for a bunch of kids because the fishing was so good here.
Yeah.
And now that stream is almost ready to blink out in terms of trout, and probably has no trout. So Silver Creek Reservoir doesn't have trout anymore, even though historical records say that it did. It gets more acidic. I don't have, on this date, I wasn't sampling the Silver Creek in that, but the pH falls from 5.4 to just like Big Creek, the mid to upper 4s here. So the best that we can ascertain is that we're on a downward slide. And because we're right near that threshold, right, the difference between a 4.8 and a 5.0 or a 5.2 can mean trout present or trout absent. I think it may be safe to assume that, and again, like Wolf Creek, right, there are trout here. Trout are present in this watershed that probably before we had decades of acid rain, that those trout were in both streams and not just one of the branches. So, but it's a really important question to answer, right? Before we just blunder in. I mean, I think stream restoration can be a problematic field because we often we want to take action, right? We want to get in there, but the tinkering with these systems can backfire. So it's an important question that we need to dig in deeper to make sure that we're not going too far. But again, going too far, right? I mean, we might be talking about we just need to get this 4.8 to 5.2, right? It might still be an acidic system, right, with a lot of acid-loving plants in the system, but it might still be in that balance where it's naturally acidic for things that can tolerate that natural acidity. And brook trout are one of those species that can, around 5.5, they start to thrive. So.
Okay, great, thank you.
Yeah.
Thanks for the talk. Very interesting, lots of information. I was especially intrigued at how you painted a temporal picture very nicely. And along those lines, my question goes back to the remediation. So, maybe you.
Told you had to stand up.
So a place like Silver Creek, we're going on, it's now been 13 years since it was constructed. What's the longevity before that needs to be recharged, especially things like the wetland cell?
Yeah.
And the limestone drain?
So most of the treatment systems that we design are meant to last for like 15 to 20 years of treatment before, they would have to be rehabbed. We're like reaching that point with some of the systems now, not so much for filling up with like metals precipitate, but we did actually just rehab a system last year that the wetland cell just became that thick with vegetation and the metal precipitate that it was starting to overtop the berms. So we did go in and have to dig that entire wetland cell out, dredge out the pond. The material went to a nearby stripping pit. So that is approved by DEP. I'm no chemist, but once iron specifically is precipitated out of the water, I can't even remember, it either has to be a really super high pH again or really low for that metal to redissolve into any like groundwater that it would be coming back out low. Okay, yeah. But so they think that's not an issue. But like I said, we're starting to have those talks now that some of our treatment systems are over 10 years old. We're still seeing good. We sample these treatment systems quarterly or twice a year to keep a tab on what the water quality is looking like, to be an indicator of when we might have to do maintenance on them. But yeah, designed for 15 to 20 years.
But they're rehabable, right? Like it's not like you give up on the system and you plow over it. You actually can kind of reboost it to continue to function.
And some of the systems have been redesigned since they've been built, especially some of the earlier ones like Bell Colliery, that was one of the first. A lot of things were learned from when that one was put in until now. So if we had grant funding available, we would go back and kind of retrofit those systems to a better fit for that site.
If I could do a quick follow-up to that. Are you familiar with some of the new research that's been coming out on mycorrhizae and its use in AMD remediation, passive and possibly active uptake of iron? It's being explored as a way to increase the longevity of these systems. Just wondering if you...
I have not. No.
So inoculating the treatment systems with terrestrial mycorrhizae?
Yes.
Is this from the northeast or in the south, northwest? Where is this research from?
It's actually some of it's taking place right here in PA, in western PA. Not like active sites, but laboratory based at this stage. So they're finding that it's, the mycorrhizae, they'll just grow on it. It just grows on its own, and it just has this uptake of iron, taking up much more iron than they thought it was capable.
That's interesting. I'll have to look into that.
All right, homework
I
video.
think it's brand new.
Yeah,
stuff
okay.
coming out.
Yeah.
You got to go to more conferences.
Yeah.
Okay. Well, I think you had a question?
Yeah, I was just curious if there's any data about groundwater, and what it will look like. But yeah, if the groundwater, if well data exists kind of in the vicinity of the streams that you're studying.
Right. I don't think any of us have started to try to, even do shallow groundwater, much less deeper groundwater. I don't know of any well sources in here. So it's an interesting question, and as we start to think about, these, kind of rainfall level pHs, and how do you get to those lower pHs? And is it shallow flow paths? Is it deep flow paths? I think about that, but I don't know that anybody has tried to delve into that. Again, Matt Shank, Pete Sharp, their crews, maybe in some of these other settings where they're seeing this acidification, they have that, maybe fortuitously with some residential wells. I think it's a really good question, but I don't have the answers.
Could you just explain in some detail what the processes, what it means for certain geologies to be cooked out by fallout of atmospheric acid?
Yeah, so I've literally got, 2 or 3 books now, and I haven't read them all, but started to look at them, I'm like, oh, this is daunting, and I wish I were a better chemist. My very superficial, no pun intended, understanding of it is that the calcium, and it's both soil and the hard rock geology, that the acidity mobilizes a lot of the calcium, the free calcium and magnesium that might be, for instance, the cementing material between the sand grains, right, in a sandstone type of environment, and a lot of that has flushed from the system or has moved down out of an active layer, deeper into soils. And so this is some of the data, and again, Pete Sharp giving us some direction, like you guys need to do some OA and V horizon soil profiles. So I think it is partly that that has been exported to some degree, either entirely from the system, or from the active part of the system, and is unavailable as rainwater, percolates through. What I don't know is, can those geologies re-weather? Like, is it literally gone entirely and there's no hope for comeback, or is it a question of time, and that if we could wait 100 years or 1,000 years, right, those soils would continue to develop and they'd have that, acid neutralizing capacity again. I haven't seen yet in anything that I've read that answers that question about the kind of time frames, and so that's something we probably have to dive into a little bit, and probably get. And one of the things I think we've heard recommendations is probably need to broaden our team a little bit and start to get some more geologists and soil scientists involved, so that we have better answers to those questions, particularly as we think about remediation, and the role of, for instance, watershed applications of dolomite to the system. Is that effective? Will that replenish it? Will that accelerate the timeline? Does it have, other negative consequences? So, but that, again, it's a very weak answer. I don't know that chemistry well, and I don't know how much of it is totally gone versus, kind of in some kind of storage. No. Perfect number of questions to still get out of here for lunch and not be the last at lunch. But if anybody has any other questions, feel free to stick around. We're happy to talk more, right?
Yep.
And get things signed by Jay. So thank you very much.